Let me introduce my friends also, Faisal Al-Taibi, Abdulaziz Al-Saad, and me, Yasser Al-Assad. We have two important objectives for our project. First, to design and build hoverboard. Second one, to investigate the parameters that affecting in the hoverboard performance by using three removable plates with different hold arrangements. Importance. We have a new application in Saudi Arabia for importance for hovercraft. You can use it in the Red Sea and the Gulf, and desert and the sand. You can use it also in the snow, and you can use it also in the ice for sport, for funny, for risk, and you can use it also in the war. The Air Forces, the British forces use it in the war, Second World War. We have two principal hoverboard, two forces: lift force that rising the hoverboard, and the thrust force that direction for forward. And this is the movement of the air flow. The movement of the air. You can see here the thrust air that come down from the rudder, and this is for rising the hoverboard aboard. The theory. We have two important theory for hoverboard in general. We have propeller dynamics, and we have propeller jet impingement, and we include or we consider the propeller jet impingement by studying the performance of jet impingement for the hoverboard. We have two important constraints: weight and safety. The weight has important dependency with the cost. We have limited with 3,500 riyal, so the weight must don't exceed the 70 kilogram, so that the weight will depend on the weight, the engine horsepower, and the size of hoverboard. If you want to 70 kilograms, this is the weight for you, and you have the area for the hoverboard. You must calculate you must get the pressure of the hoverboard for getting the engine, the size and the speed for hoverboard. Safety. Second one is safety. Safety is important. Safety important constraint for our the standard and codes for engineering must consider that any rotating shaft or any rotating bar, you must enclose it with safety constraint, and you must also like this one, and must also you put anti slip for the rider for don't slip on the hoverboard. Hoverboard, what we do, it's hoverboard two design. First one for experimental work, and this will explain Suleiman. Second one, the hoverboard, the prototype, this one, and will explain Abdulaziz. And this is experimental work with my colleague Suleiman.
Our experiment work in the previous semester was in calibrating the external blower and studying the effect of jet impingement hold and slip on hoverboard. Here is the experiment measuring installment test for 40 nanometer to measuring the velocity profile, velocity speed, and the drug DBI 700 pressure indicator. And here we have the three removable plates which we study the effect of impingement hold, and all is converging inside. Here the three sides of removable plate. This is node, and this is the slit, and this is circulated, but all of them are the direction to inside, conversion. Here the schematic of experimental setup. As you see the flow coming from the centrifugal fan, and we connect it to straight duct to have good velocity profile, and connected to flexible duct to have free movement. And this is the model of hoverboard. Here we put a straightener plate, and here the remover plate, which we use 3 remover plates. And this is the result of our experiment with my colleague Peter.
The first section of experimental work is calibration of statement power. The volume flow rate is calculated from the velocity profile in 2 perpendicular planes, horizontal and vertical, by using this formula. And this figure get from horizontal velocity profile at fully open valve, and we get this profile by measuring the velocity at a different positions by using anemometer device. Then we calculate Q equal 1.1627 meter cube per second. And the same thing for vertical plane. Then we take the average value between horizontal and vertical, which comes 1.1238. When we change the valve position 10 times from minimum valve opening to maximum valve opening, we get this relationship between Q and P, and this gives the characteristic of the blower which is used to operate the hoverboard model. The second section of experimental work is performance of hoverboard. It includes 2 sections, height of hoverboard and pressure under hoverboard. This figure shows the relation between volume flow rate and the height of hoverboard, and the height increases with the volume flow rate and decreases with the weight of the hoverboard. After a certain volume flow rate, the increasing the volume flow rate has no effect, and this conclusion is very important to design a hoverboard model. Other section is the pressure under hoverboard. We can calculate the pressure under hoverboard by using this formula, where V out is the jet velocity and Vi is upstream velocity, and we can neglect it compared with the V out because it's very small. Then we get this relation between pressure and the height. Also it's increasing with the pressure. At a certain pressure there is no effect in the height. At the end of our experimental work, we found this the prepared removable plate, which we use it in the hoverboard. Hoverboard prototype with my colleague Abdullah.
The specification of our hoverboard, as shown in the table, capacity for 1 person, and the speed from 20 to 40 kilometers per hour, and the dimension is 1.5 meter by 0.62 meter, and we select this dimension to get more comfortable for the rider, and the empty weight is 70 kilograms. Hoverboard consists of 4 main parts: engine, structure, scales, and handles control. The number one is the engine, and its specification, as shown in the table in detail. It has 4-stroke and 6 horsepower with the vertical shaft. The structure of our hoverboard is made of sandwich of foam, and there are three plates of foam under the engine, and the upper plate and the lower plate is made of plywood, and we covered by fiberglass to get more stronger. We use this skirt to save the air under the hoverboard to increase the pressure. The hand control is used for control the speed and direction. hand control. You like this? If you do that like this, you will remove the rudder. And this one for the increasing the speed.
The cost analysis of our hoverboard as shown in the table, and we have the total cost is 3,313 Saudi riyals, and this cost within the budget. And this concluding with my colleague Sulaiman.
Our conclusion in our project it's designed and constructed and operated. The first one is the experimental work of hoverboard executed to find the performance of hoverboard, flow rate and pressure under the hoverboard. The second one is to design and build hoverboard within our constraint, the cost and the safety. Our recommendation for other students in the future is to maximize the pressure under hoverboard using the effective hold arrangement, and we recommend them to use the preferred remover plate which we have it. And minimize the weight of engine and material. The third one is to design muffler for hoverboard engine to reduce the noise coming from the engine.
Okay, shukran.
We want to show you
the video of operating the hoverboard. This is the handheld control. This one, and increasing the speed, and the movement of the rudder up and down, removing the rudder right and left, up for right. Try to push inside. Getting some clear movement. And thank you.